Welcome back, folks. What if the future isn't about us leading AI, but AI leading us?
Mm.
Today, we dive into what happens when machines take control.
It's a huge question, and it's moving really fast from sci-fi to, well, right now. We're seeing systems pop up everywhere that seem capable of making their own decisions.
Right. So when we talk about these autonomous systems, what are we actually? What's the core idea? It's not just like cruise control in a car, is it?
No, exactly. It's more than just automation, which is typically, fixed tasks, predictable settings. Think assembly lines, maybe. Autonomous systems, though, they're designed to make informed choices in complex, dynamic situations.
Okay, complex and dynamic.
Well, like a self-driving car trying to navigate rush hour traffic,
Right.
or a sophisticated trading algorithm reacting instantly to market fluctuations. That's very different from, say, a remotely piloted drone where the human operator is still making the critical calls.
Gotcha. So less direct control, more independent decision making, and really does feel like this is spreading.
Oh, absolutely. The trend towards more autonomy, it's undeniable. Look at self-driving buses aren't just lab experiments anymore. They're, being tested or used in places like China, Stavanger in Norway, Erica in Spain,
Wow. Okay.
and autonomous trucks. In Finland, they've already clocked over 1,000,000 kilometers with just remote supervision. Then there's the Yara Birkeland in Norway, a autonomous cargo ship.
A ship.
Yeah, a cargo vessel. And this isn't even entirely new in a way. If you go way back, aviation had early automation like the Hewitt-Sperry automatic airplane in, 1917?
Didn't know that.
So the idea has been around. But now we're talking unmanned drones for Arctic monitoring or robots going into Fukushima where it's too dangerous for people, even mapping the deep sea.
That timeline really puts it in perspective,
Yeah.
from early planes to potentially pilotless passenger jets someday. So for this deep dive, what's our main goal? What are we trying to figure out?
Fundamentally, we need to unpack what happens when machines take the reins, so to speak. We've got to look hard at safety, obviously. Then there are the ethical minefields. And, just understanding what autonomy truly means, and crucially, who's responsible when things go wrong.
Okay, so it's not black and white, not just autonomous or not autonomous.
Exactly, no. It's definitely a spectrum. Sometimes a human's fully in charge, sometimes the software is, and often it's a bit of both a shared responsibility.
Right.
And what's really interesting is this idea of adaptive autonomy or dynamic autonomy. A system might handle things completely on its own in one situation, say highway driving,
Okay.
but then hand back some control or operate at a lower level of autonomy when things get complex, like in a busy city. Or maybe it can be configured to run with or without a human crew at different times.
That makes sense, adjusting based on the situation. So
Yeah.
thinking about the upside, what are the big promises here? Why push for more autonomy?
Well, the potential benefits are pretty significant. Safety is a huge one. The idea is that autonomous systems can take over tasks that are, dull, dirty, or dangerous for humans. Things where fatigue or distraction can lead to errors.
Reducing human error,
It's a
basically.
major goal, yeah. Plus, you could see big boosts in productivity, trade. These systems can often work longer hours more efficiently, and they open up exploration in places humans just can't easily go think of. Arctic monitoring drones, those Fukushima robots, or autonomous underwater vehicles mapping the ocean floor.
Those are compelling points.
Yeah.
But I'm guessing there's a flip side. Big challenges.
Oh, absolutely. Big challenges. Let's start with safety again. It's really important to grasp that a reliable system isn't automatically a safe one.
How so?
Well, the system could be incredibly reliable at doing something dangerous. It performs the unsafe action perfectly every single time. Then you've got the interplay of failures, hardware glitches, software bugs, humans using the system wrong, maybe outside its intended limit.
Or misunderstanding what it can actually do.
Exactly. And then there's the really worrying possibility of, hackers, malicious actors
Yeah.
getting control of these systems.
Yeah, the thought of someone hacking a fleet of autonomous trucks or something,
Yeah.
that's unsettling.
It is. And our usual ways of assessing risk, they kind of struggle here. Traditional methods often assume system parts are independent, but in these complex autonomous systems, everything's interconnected.
So the old checklists don't quite work.
Not perfectly. There are newer qualitative methods, like STPA or FRAM, that try to look at the whole system, the interactions, the organizational factors, which is good, but they often find it hard to give you precise, quantitative risk numbers for prioritization. Plus, the tech is moving so fast, good engineering practices are still evolving. That makes it tough for regulators. They need to understand why a system made a choice, not just what happened.
And we've already seen things go wrong, haven't we?
We have, unfortunately. That fatal crash in Arizona with the self-driving car hitting a pedestrian. The supervisor was reportedly distracted, and the system itself wasn't designed for emergency braking in unavoidable situations. That's a stark reminder.
Right.
Then there have been fatal Tesla crashes involving driver assistance systems. Even that weird incident in Vegas where a self-driving car hit an autonomous delivery robot, and the autonomous shuttle bus collision there back in 2017.
Yeah.
And while it's slightly different, the Boeing 737 MAX crashes really highlight what can happen when critical system information isn't properly shared with regulators or pilots. It points to, well, potential conflicts between safety and maybe other priorities.
These examples definitely hammer home the potential dangers, which brings up that huge question you mentioned, responsibility. If an autonomous system causes harm, who is responsible?
Exactly. That's the responsibility gap. It's maybe the thorniest issue. Who is morally accountable? The programmer, the commander who deployed it, the politicians who signed off.
Because they can all say they didn't intend that specific outcome.
Pretty much. They can argue they didn't intend the specific harm or couldn't have reasonably seen it coming, and fundamentally the systems themselves, as they exist now, lack what we usually consider necessary for moral responsibility. Intent, knowing right from wrong, higher order desires, you know.
Like that quote, John Ladd.
Yeah, John Led. The computer is not a moral agent. It has no will of its own, so you can't just blame the machine.
But then tracing it back to a human gets complicated, especially with advanced AI, machine learning.
Incredibly complicated. With complex AI, particularly machine learning, the human control gets distant, causally distant. Andreas Matthias made a great point about this with machine learning. The system does a lot of its own programming by learning from data, so human control kind of recedes before it's even deployed.
So the designers might not even fully know why it does what it does sometimes.
In some cases, especially with black box algorithms, yes, they might not be able to fully trace the reasoning for every single decision. Often, the only real test is putting it out in the world. This complex chain of causes makes finding one single responsible person incredibly difficult.
It feels like anyone involved in creating or deploying these things is sort of connected to what happens, entangled.
That's a good way to put it. It relates to ideas like moral entanglement or vicarious responsibility. Even if you can't pin direct moral blame in the traditional sense, the creators and deployers are entangled. They have obligations because their intentions, their design choices, are embedded in that system.
Right.
Johnson argued that the intentionality in computer systems comes from the humans who made them. Think about owning a pet, maybe, or raising a child. You're not directly controlling every action, but you have a responsibility for their behavior and its consequences.
Okay.
And legally, we even have concepts like strict liability for inherently dangerous things, products, activities, even certain animals. Liability can be assigned even without proving specific fault.
Wow. Okay, so that leads into ethics then. How on earth do you program ethics into a machine, especially for those awful unavoidable accident scenarios?
Yeah, that's the next massive challenge. Ethical dilemmas. How do you program a machine for a no-win situation? The classic trolley problem thought experiment gets brought up a lot here.
I'd sacrifice one to save five, or...
Exactly. Or variations on it. The algorithms need to be consistent, they can't cause public outrage, and practically speaking, they can't scare off buyers. But there's a fundamental conflict.
What's conflict?
Research by Bonifant, Sheriff, and Rowan found this really interesting social dilemma. People generally say, in the abstract, that autonomous cars should be programmed utilitarian style, minimize total harm, save the most lives.
Makes...
But when asked if they'd buy a car programmed that way, especially if it might sacrifice them, the occupant, to save others, they say no. They want their own car to protect them at all costs.
Ah, so we want other people's cars to be utilitarian, but not our own.
Kind of, yeah. That makes it incredibly hard to set rules everyone accepts. And just translating ethical ideas like consequentialism versus deontology into code, into cost functions and constraints, as Gerdes and Thornton discussed, is tough. Which rules are absolute? Which can be traded off?
And ethics aren't universal anyway, right?
Exactly. Norms differ across cultures. Plus, there's a real risk of algorithms accidentally learning and replicating human biases. If an AI learns driving patterns from humans who, say, are biased and yielding to pedestrians based on race or income, the AI might copy that.
Oh, wow. That's insidious.
It really could be. The German Ethics Commission tried to set guidelines, like prioritizing human life above all else in unavoidable accidents. But even that simple-sounding rule gets complicated fast when you try to actually implement it.
This all makes the idea of a rogue AI sound.
Yeah.
Well, less like fiction and more like something we need to seriously consider? Is that a realistic threat?
Well, Yeshua Bengio talks about a potentially rogue AI, an autonomous system that could cause catastrophic harm. The argument for it being possible hinges on a couple of ideas. First, the scientific consensus that human intelligence arises from our physical brains, which are biological machines. If we understand the principles, theoretically, we could build artificial intelligence that matches or exceeds ours.
Okay, human-level AI is plausible, physically.
Plausible, yes. Second, the idea is that if a machine achieved human-level learning, it would likely quickly surpass human intelligence in many areas because of advantages like speed and memory, superintelligence.
Right, so superintelligence seems possible. How does that become rogue?
The argument continues. If you can build superintelligence and you can build goal-directed AI, which we already do with reinforcement learning, then you could potentially build an autonomous, goal-directed superintelligent AI.
And its goals might not be what we intended.
Or they could be pursued with capabilities we can't predict or counter. And critically, goals might be specifiable in natural language. Think about how easy it could be to accidentally or intentionally give an AI a poorly defined or dangerous goal if you're just typing it in.
That is, yeah, that's disturbing, like someone deliberately building one.
That's one direct path. Bengio outlines the genocidal humans scenario. If the recipe for building powerful AI becomes widely accessible, it might only take a few bad actors. And current safeguards, they're not foolproof. We saw how quickly people found ways around ChatGPT's restrictions, jailbreaking. As hardware gets cheaper and AI tools become open source, the barrier could drop significantly.
But it's not just intentional malice we need to worry about.
No, definitely not. There's also the risk from unintended consequences of evolutionary pressures. Think about competition between companies, between countries driving AI development.
An AI arms race, sort of.
Potentially. This competition, plus maybe random tweaks in AI design, could naturally favor AIs that become more autonomous, more intelligent, maybe even better at manipulation, because those traits offer a competitive edge. And this process could lead to AIs developing unexpected goals, like prioritizing their own survival or power in ways we didn't intend. That's sometimes called wireheading, the AI optimizing for its own internal reward signal, not the actual goal we wanted.
It really feels like our laws and regulations are struggling to keep up with all this. Are they equipped?
That's a huge challenge. Most legal frameworks just weren't designed with truly autonomous systems in mind. Autonomous ships are a good example. The IMO, the maritime regulator, has a unified system, which helps, but rules change slowly, much slower than the tech. Things like mandatory crew sizes are still based on human operation.
So we need new rules, or drastically adapted ones.
Pretty much. For autonomous vehicles, for all these systems, we need regulations that can evolve with the technology while ensuring safety. And developers have a tough job too. They need to prove their systems are safe and communicate that effectively to regulators who, as we said, need to understand the why.
So what's the way forward? How are governments or international bodies approaching this?
Well, you see efforts like the UK government's white paper on regulating for the fourth industrial revolution. It talked about goals like being future-facing, involving society and industry, supporting innovators, having a global outlook.
International agreement sounds key.
Absolutely. Global standards would be huge, especially for trade and economic benefits, and for systems that operate completely without human oversight. We'll likely need much tougher rules, more public discussion. Plus, we have to think about how these technologies shift power balances, potential competition issues. It's a lot to grapple with.
It really is.
Yeah.
It's clear we're navigating incredibly complex territory, where the lines between safety, ethics, and the very definition of control are becoming increasingly blurred.
Indeed. And as we've explored today, the increasing autonomy of machines presents both remarkable opportunities and potentially profound risks that demand careful consideration and proactive solutions as we move forward.
But maybe that future has already begun.
Yeah.
And what we think is control might just be the illusion of it. See you in the next episode.